All right, so we talked about the equations of a function. A lot of times we'll see them represented as something like this: f of x equals 2x minus 5. We know that's a function based on just the equation, because we see this f of x or something like it, g of x, k of x, could be anything, but we see that, we know it's a function. And this is the name of the function, this is the input. Now, this one in particular, though, is very similar to one equation that we've talked about before, isn't it? Isn't this like y equals mx plus b? Yes, very much like y equals mx plus b. However, now it's in the f of x form. So this, if we have similar to the y equals mx plus b, if we have f of x equals mx plus b, what do we know about that particular equation, that function? What shape graph does it have? It's going to be a line, right? This is going to be a line. So this is called the linear function. And just like before, the graph's going to be a line. And what do we know about the line? Slope is m, y-intercept is b. All right? Same thing. Very same thing. Just we're replacing the y by f of x. Y and f of x are synonymous, so this is very same thing. So what have I got here? Well, I've got m, the slope is 2, b, the y-intercept is -5. And so if I wanted to graph this function, well, there's a number of ways I could do it, but that's one way of doing it. We did this earlier. What do? Well, the b tells me the y-intercept, so let's go to the y-axis here at -5. And then the slope, well, we can say that's 2 over 1, rise over run. And so from that y-intercept, rise 2, run 1. Rise 2, run 1. So there's another point, and you can keep doing that. But okay? And there's various other ways you could do that. When we could use a table, we could use intercepts, the x and the y-intercept, find both of those. But yeah, this is very same thing. Y equals mx plus b, f of x equals mx plus b. You can do the same thing. All right? Okay, well, we'll talk a lot about some different functions more later on, but let's say we came across this one. F of x equals 2x squared minus 4x plus 3. Okay, perhaps you know more about this than we'll talk about right now, but just with what we've talked about, the way we're going to do this one is, graph this one, is using table. An x, y chart, table. And what's playing the role here of y, though? This is y, isn't it? The f of x value is my y value. So I can get x and y values to plot on the graph just by using a table here. We did, -3 to +3 when we were doing them earlier. So let's just look at that. Just choosing the x values to be -3 to +3. And then we can get the y values off of that. Like we said, it's the y is the f of x value. And so the x value here is -3. So the y value is just going to be, plug in, -3, right? And see what that'll give us. That'll be 2 times 9 plus 12, won't it? Plus 3. So that's a pretty big one. That's 18, 12, and 3, 33. Does that sound right? 33 for the negative 3. Do the same thing for the rest. All right, so x is negative 2. Do the same thing. 2 times negative 2 squared minus 4 times negative 2 plus 3. Well, that's 2 times 4. That's positive 8 plus 3. 8 plus 8 plus 3. I'm getting 19. Sound okay? 19. Negative 1, so we have 2 times negative 1 squared minus 4 times negative 1 plus 3. And that's 2 times 1. That'd be plus 4. That'd be plus 3. 2 plus 4 plus 3. I'm getting 9. And the rest of them a little easier without the signs. What about for 0? Well, 2 times 0 squared minus 4 times 0 plus 3. That's 0. That's 0. So I'm getting 3. 1. 2 times 1 squared minus 4 times 1 plus 3. Well, that's 2 minus 4 plus 3. That's going to be a negative 2 plus 3 is 1. Positive 1. 2. 2 times 2 squared minus 4 times 2 plus 3. It's 2 times 4 is 8. Minus 8 plus 3. Back to 3. And then for 3, 2 times 3 squared minus 4 times 3 plus 3. 2 times 9 is 18, minus 12 plus 3, 9. All right, and so that gives us the shape here of my graph. It's going to come out looking like, all right, so I need to go 33. How about we go by 3s here? 3, 6, 9, 12. 15, 18, 21, 24, 27, and 30. 33. One more dollar. All right. So at negative 3, I get 33. So that one's up here. Negative 2, I'm at 19, so that's going to be right about here. Negative 1, I'm at 9, so that's right there. 0, 3, 1, 1, 2, 3, and 3, 9. So there you go. And that's just going to keep going symmetrical like that. With me on that? Is that okay? All right. So, yeah, using a table, that is effective. We'll talk a lot more about these x squared graphs later on, but for right now, we'll just utilize a table to graph those. All right. Now, like I said, we're talking about graphs of functions. One other thing we can note about graphs of functions, there's a test to determine whether a graph is a graph of a function or not. It's called the vertical line test. And here's how it works. A graph is the graph of a function if no vertical line intersects the graph in more than one point. A graph is a graph of a function if no vertical line intersects the graph in more than one point. Or another way to put it, if a vertical line does intersect in two or more points, it's not a function. Saying the same thing. All right. For example, we know this one is a function, but the one I have graphed previously, I know that one is a function, but here's what this is saying. If I draw vertical lines through this graph, no vertical line intersects it in more than one point, does it? Because if I draw a vertical line here, it intersects it in one point. If I draw a vertical line here, it intersects it in one point. If I draw a vertical line here or here, it's only intersecting the graph one point. So that's a function. What happens on a function? Okay? All right, so let's test out a couple of functions using that test there. All right. Number one is going to be it's going to be a V-shaped graph. The axes, and here comes the V. So the question is, don't know the equation. The question is that a function? Is the V-shaped graph, this V-shaped graph anyway, is this one a function? You would say yes or no. 50-50 shot. Yes, it is. Okay. And why would you say that? Well, again, the vertical line test. VLT. Right? Because if I draw vertical lines anywhere on this graph, here, 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 it's intersecting in one point only, right? Doesn't violate the vertical line test as far as points go. So by the vertical line test, yeah, it hits only one point. All right, number two, though, let's look at that one. It's kind of like the one we did earlier, but kind of sideways. Is that one a function? No. No, it wouldn't be, because draw just about anywhere, draw a vertical line, right? 1, 2 points of intersection on that one right there. So that would not be a function, because it fails the vertical line test. Hits it in more than two points. To fail the vertical line test, it hits in 2 points a vertical line somewhere on the graph. It could just be in one place, but if it hits the graph vertically more than 1 point, it fails the vertical line test there. Now, I will do another one here in just a second, but why does that work, or why is that? Well, it's back to the definition. The definition of function says you've got one x that goes, for every x, you go to one y, right? Which is the case for the two we've looked at. For example, this x right here, whatever it is, it goes to this one y value right there. Same for all those others, okay? This x goes to that y. This x goes to that y. However, what about this one? Well, here's an x value, and it goes to this y value, call it y1, and it goes to this value, call it y2. That one x value goes to those two y values, doesn't it? That's why this vertical line test works. It's the very same thing as the definition, but we call it the vertical line test. Okay, number 3. Number 3, it's kind of broken up a little bit. 2 parts. We've got a part this way, part going that way. Is that one a function? Can you have that sort of thing? Sure. You can have that do that. Does it pass the vertical line test? I think so. Yeah, if I draw a vertical line anywhere out here, intersects it in 1 point, anywhere you want, right? Draw a vertical line there, Yeah, it's intersecting at only at one point. Over here, same thing, just kind of the mirror image, if you will. Yeah. Each vertical line is hitting it at one point. So yes, this is a function. Okay? All right.